So how to identify carbohydrate in any kind of a solution or the samples. So to identify the carbohydrate, we completely depending on the chemical nature of the carbohydrate itself. I mean, when carbohydrate is present in a different type of a chemical environment, carbohydrate used to show different type of a chemical reaction or the chemical properties like oxygen formation, dehydration, reducing properties, and the tautomerization. If we take the example of the tautomerization, what actually happened in a tautomerization? Tautomerization is nothing but a movement of a hydrogen atom from one carbon atom to another carbon atoms in the carbohydrate molecules. When it is happened when you keep the carbohydrate like monosaccharide for a long period of time in an alkaline solution. If you keep that carbohydrate means monosaccharide in a alkaline solution, they used to become the inediol compounds. So now this tautomerization properties of the carbohydrate used to fuel the reducing power of the carbohydrate molecules. By utilizing the reducing power of the carbohydrate molecules, we can reduce the cupric ion to the cuprous ion. So in different taste, the environmental condition or different type of addition of the other chemicals with the copper ion have a different taste. Like for example, there is a Felling's solution is there, or the Felling's taste is there is a Benedict taste is there, and another taste is the Barford taste. So these three tastes can say you that in your solution is there any kind of a reducing sugar is present or not. Now we will come to the another properties of the carbohydrate, that is the dehydration. When dehydration happened, so if you keep the carbohydrate molecules for a long period of time, or suppose if you keep the carbohydrate molecules with the sulfuric acid, then what will happen? The sulfuric acid will extract water molecule from the carbohydrate molecules. So from the carbohydrate molecule, 3 water molecule will release. Now this one will give you the perfural forms. In case of a glucose, hydroxymethyl perfural used to form, and in case of a pentose, perfural is formed. Now this perfural can react with the alpha naphthol. When they react with the alpha naphthol, they used to give a different type of a color compound. This is called a Mollis test. Now we will come to the oxygen formation. Why I am saying oxygen formation in the last? Actually, oxygen formation is very interesting. When it is happened, when you boil with the monosaccharide with the phenyl hydrazine, it used to give the oxygen formation. It used to give the oxygen compounds like carbohydrate, like glucose or other monosaccharide with the phenyl hydrazine, it used to give the hydrogen molecules. Now if it is a glucose or the mannose, so they used to give you a hydrogen molecules. That hydrogen, if you see under microscope, you can see the crystal structure, and that crystal structure is a needle-like crystal structure is present. But in case of a maltose, that is a disaccharide. The maltose in presence of a phenyl hydrazine, under microscope it used to give a sunflower like a crystal structure. And the lactose in presence of a phenyl hydrazine, it used to give a powder, puffy powder kind of a structure. So that's why they used to give a different type of a crystal structure. So these are the basic 3 tests by which we can identify, yes, in that solution the carbohydrate is present. So whatever it is, monosaccharide or the disaccharide, and these all are the depending on the reducing sugar. So these all are the basic tests by which we can identify if there is a carbohydrate molecule is present in a solution.